Imagine an animal so massive that giraffes would look up to see its face. Picture a creature weighing as much as 4 elephants combined, walking through forests and eating from treetops like they were bushes. What if I told you that such a giant actually existed, roaming the earth millions of years ago? Today, we're exploring the incredible story of Paraceratherium, the largest land mammal that ever walked our planet. And we're asking the ultimate question: what if this colossal beast were alive today? Now we continue our documentary with extinct species today. Paraceratherium transoralicum, a name that doesn't roll off the tongue easily, and a creature that most people have never heard of. Yet this animal represents one of nature's most extraordinary achievements. Standing taller than a giraffe, heavier than any elephant, and more powerful than any land mammal alive today, Paraceratherium was the undisputed giant of its time. The first fossils of Paraceratherium were discovered in the early 20th century across Central Asia, primarily in what is now Pakistan, Kazakhstan, and China. British and Russian paleontologists unearthed massive bones that initially baffled scientists. The sheer size of these remains suggested something unprecedented. As more fossils were found and pieced together, the true magnitude of this creature became apparent. Paraceratherium lived approximately 34 to 23 million years ago, during the Oligocene epoch. This was a time of dramatic environmental change. The world was cooling after the warm Eocene period. Tropical forests were giving way to more open woodlands and grasslands, and mammals were evolving into larger and more diverse forms. In this changing world, Paraceratherium emerged as the supreme herbivore. The statistics of Paraceratherium are staggering. Standing at the shoulder, it reached heights of 4.8 to 5.5 meters. To put this in perspective, that's taller than most single-story buildings. Its head could reach up to 8 meters above the ground when fully extended, allowing it to browse from trees that no other animal could access. In length, from nose to tail, Paraceratherium measured approximately 7.4 to 9 meters. Its weight is estimated between 15 to 20 tons, with some individuals possibly reaching even greater masses. Compare this to modern elephants. The largest African bush elephants stand about 3.3 meters at the shoulder and weigh around 6 tons. Paraceratherium was nearly twice as tall and more than 3 times as heavy. Even the extinct woolly mammoth, often considered one of the largest land mammals, was smaller than Paraceratherium. Despite its enormous size, Paraceratherium was not a slow, lumbering creature. Its legs were long and columnar, designed to support its massive weight while allowing relatively efficient movement. Scientists estimate it could walk at speeds of 10 to 15 kilometers per hour when moving normally, and possibly reach short bursts of 25 to 30 kilometers per hour if threatened. For an animal of such size, this was remarkably agile. The skull of Paraceratherium reveals fascinating details about its lifestyle. Unlike modern rhinoceroses, Paraceratherium had no horns. Its skull was elongated, with a relatively small brain cavity for its body size, but large nasal openings suggesting a well-developed sense of smell. The teeth were specialized for browsing, with high-crowned molars perfect for grinding tough vegetation. The front teeth included prominent incisors that could strip bark and pull down branches. Most intriguingly, Paraceratherium had an extremely long neck. While not as long proportionally as a giraffe's, it was still remarkable for such a large animal. This neck allowed Paraceratherium to reach high into trees, accessing food sources unavailable to other herbivores. Imagine a creature with the body of an elephant, the neck of a giraffe, and legs like tree trunks. That was Paraceratherium. The world of the Oligocene was very different from today. Global temperatures were dropping, but the climate was still warmer and more humid than the present. Central Asia, where Paraceratherium thrived, was covered in open woodlands, scattered forests, and vast floodplains. Rivers crisscrossed the landscape, creating fertile valleys where vegetation flourished. This was the perfect habitat for a giant browser. Paraceratherium's diet consisted primarily of leaves, branches, and bark from tall trees. It was a selective feeder, choosing the most nutritious parts of plants. With its height advantage, Paraceratherium could access the highest branches, leaving lower vegetation for smaller herbivores. An adult Paraceratherium would need to consume approximately 400 to 600 kilograms of plant matter daily to sustain its massive body. That's roughly the weight of 6 adult humans in food every single day. The feeding strategy of Paraceratherium had a profound impact on its environment. By browsing on tall trees, it prevented forests from becoming too dense. This created a more open woodland environment, which benefited other species. Smaller herbivores could graze on the grass and low shrubs, while other browsers could feed on mid-level vegetation. Paraceratherium was an ecosystem engineer, shaping the landscape simply by eating. Unlike elephants, which live in complex social groups, Paraceratherium was likely more solitary. The massive food requirements of such a large animal would make group living difficult. Scientists believe adult Paraceratherium roamed alone or in very small groups, with males and females coming together only for mating. Mothers would care for their young for several years, teaching them which plants to eat and where to find water. The reproductive cycle of Paraceratherium was slow. Females probably gave birth to a single calf after a gestation period of 15 to 18 months. The calf would be born relatively large, perhaps 200 to 300 kilograms, but still completely dependent on its mother. It would take 10 to 15 years for a young Paraceratherium to reach full adult size. This slow reproduction rate meant that Paraceratherium populations were never very large, and the species was vulnerable to environmental changes. Predators were not a significant threat to adult Paraceratherium. Simply put, nothing could take down a healthy adult. The sheer size and strength of Paraceratherium made it virtually invincible. However, young calves were vulnerable. Large predatory mammals of the time, such as entelodonts and early big cats, could potentially attack isolated young. This is why mother Paraceratherium were fiercely protective of their offspring. The extinction of Paraceratherium around 23 million years ago coincides with significant environmental changes. The climate continued to cool and dry, and the open woodlands that Paraceratherium depended on began to transform into grasslands. Trees became sparser and shorter. For an animal that specialized in high browsing, this was catastrophic. The food sources Paraceratherium relied on were disappearing. Additionally, competition increased. New herbivores evolved that were better adapted to the changing environment. Early horses, antelope-like creatures, and other grazers thrived on the expanding grasslands. Meanwhile, Paraceratherium, with its specialized anatomy for high browsing, could not adapt quickly enough. The combination of climate change, habitat loss, and increased competition led to the gradual decline and eventual extinction of this magnificent giant. Today, the closest living relatives of Paraceratherium are rhinoceroses. Modern rhinos are much smaller and have evolved horns for defense and competition. They occupy different ecological niches, primarily as grazers and mixed feeders rather than specialized high browsers. The evolutionary path from Paraceratherium to modern rhinos represents millions of years of adaptation to changing environments. Now, let's engage in a fascinating thought experiment. What if Paraceratherium still existed today? How would our world be different? The implications are both wonderful and problematic. First, consider the habitat requirements. Paraceratherium would need vast areas of open woodland with abundant tall trees. In today's world, such habitats are increasingly rare. Deforestation, agriculture, and urban expansion have drastically reduced suitable environments. Perhaps Paraceratherium could survive in parts of Africa, where savannas with acacia trees exist, or in Southeast Asian forests. But even these areas are under pressure from human activities. The daily food requirement of 400 to 600 kilograms means that a single Paraceratherium would have a significant impact on vegetation. In protected areas like national parks, this could be beneficial, preventing overgrowth and maintaining open woodland habitats. However, in agricultural regions, Paraceratherium would be seen as a pest. Imagine this giant stripping entire orchards overnight or demolishing carefully cultivated forests. Human Paraceratherium interactions would be complex. Unlike predators that pose a direct threat, Paraceratherium would be a herbivore. It wouldn't hunt humans. However, its sheer size would make it dangerous. An accidental collision with a Paraceratherium could be fatal. A startled or aggressive individual could easily crush vehicles or buildings. During mating season, males competing for females would be particularly dangerous, as they might use their massive bulk to push and shove rivals. Would Paraceratherium fear humans? Probably not. Its size gave it security throughout its evolutionary history. Adult Paraceratherium had no natural predators, so they didn't evolve fear responses to threats. This fearlessness could lead to conflicts. Paraceratherium might wander into human settlements looking for food, causing damage and chaos. Conservation of Paraceratherium would be an enormous challenge. Modern conservation efforts struggle to protect elephants and rhinoceroses, which are much smaller. Paraceratherium would require reserves of unprecedented size. We're talking about areas of thousands of square kilometers with specific vegetation types. The cost of maintaining such reserves, protecting them from poaching, and managing human-wildlife conflict would be astronomical. Poaching would indeed be a severe threat. The sheer size of Paraceratherium bones and potential value in illegal wildlife trade would make it a target. Additionally, if Paraceratherium damaged crops or property, local communities might kill them in retaliation. Even with legal protection, enforcing conservation laws would be difficult. On the positive side, Paraceratherium would be an incredible draw for ecotourism. Imagine safari tours to see these towering giants browsing from treetops. The economic value of Paraceratherium tourism could potentially fund conservation efforts. Specially designed viewing platforms would allow tourists to observe Paraceratherium at a safe distance. The experience would be unforgettable, combining the awe of seeing elephants with the uniqueness of watching an animal reach heights no other land mammal can achieve. Scientifically, living Paraceratherium would be invaluable. Researchers could study its physiology, behavior, and ecology in real time. Questions about its metabolism, how it supported such massive weight, its social structure, and its impact on ecosystems could be answered. The creature's cardiovascular system alone would be fascinating. How does blood pump up a neck several meters long? How much does a Paraceratherium heart weigh? These questions could revolutionize our understanding of large animal biology. Modern technology would allow unprecedented study. GPS collars could track Paraceratherium movements across vast territories. Drones could observe behavior without disturbing the animals. Genetic analysis could reveal details about population structure and health. Camera traps would document daily activities. This data would not only teach us about Paraceratherium, but also provide insights applicable to conserving other large herbivores. In terms of ecosystem impact, Paraceratherium would be a keystone species. By browsing on tall trees, it would maintain open woodland habitats. This would benefit numerous other species, from birds nesting in scattered trees to small mammals living in the undergrowth. Grasslands beneath the trees would support grazers. The dung of Paraceratherium, produced in massive quantities, would fertilize soil and disperse seeds, promoting plant diversity. However, there would be challenges. In some regions, Paraceratherium might overbrowse, damaging forests before they could regenerate. Balancing Paraceratherium populations with environmental carrying capacity would require careful management. Translocation programs might be necessary to prevent localized overgrazing and to establish new populations in suitable habitats. Climate change adds another layer of complexity. Rising temperatures and changing rainfall patterns are altering habitats worldwide. Would Paraceratherium be able to adapt to these rapid changes? Its evolutionary history shows it struggled when habitats transformed millions of years ago. In the modern era, with climate change occurring over decades rather than millennia, adaptation would be even more challenging. Genetic diversity would be a concern. If Paraceratherium populations were small and isolated, inbreeding could become a problem. Genetic management, possibly including assisted reproduction or even cloning technologies, might be necessary to maintain healthy populations. This raises ethical questions about human intervention in nature. Culturally, Paraceratherium would become iconic. Indigenous peoples and regions where it lived would develop folklore and traditions around it. Paraceratherium would appear in art, literature, and media worldwide. Children would grow up learning about this gentle giant. It would rival elephants and whales as symbols of conservation. The coexistence of humans and Paraceratherium would require a fundamental shift in how we view land use. We would need to accept that some areas are for wildlife, not development. Corridors would need to be established to allow Paraceratherium to move between habitats. This would benefit countless other species as well. Education would be key. Teaching communities living near Paraceratherium about the animal's behavior, how to avoid conflicts, and the economic benefits of conservation would be essential. Compensation programs for crop damage could reduce retaliation killing. Community-based conservation, where local people actively participate in and benefit from protection efforts, would be the most sustainable approach. International cooperation would be necessary. Paraceratherium would likely live across multiple countries. Coordinated conservation policies, anti-poaching efforts, and habitat management would require treaties and agreements. Organizations like the United Nations, World Wildlife Fund, and International Union for Conservation of Nature would play crucial roles. The legacy of Paraceratherium, whether extinct or imagined as living today, is profound. It represents the incredible diversity and adaptability of life. It reminds us that Earth has been home to creatures beyond our wildest imagination, and it challenges us to think about what we're willing to do to preserve the natural world. In reflecting on Paraceratherium, we also reflect on ourselves. Are we good stewards of the planet? Can we create a world where both humans and wildlife thrive? The extinction of Paraceratherium 23 million years ago was a natural process, driven by environmental changes. But extinctions today are largely driven by human activities. We have the power to prevent loss, but also the responsibility. Paraceratherium's story is ultimately hopeful. It shows that life can achieve incredible forms, adapting to fill niches and thrive in diverse environments. It also shows that nothing lasts forever, that change is constant, and that resilience and adaptation are keys to survival. These lessons apply to all species, including our own. As we stand at a critical juncture in human history, facing climate change, biodiversity loss, and environmental degradation, the ghost of Paraceratherium asks us a question. What kind of world do we want to leave behind? One where giants still roam, where nature is wild and free, or one where only memories and fossils remain? The choice, ultimately, is ours. Paraceratherium transoralicum, the largest land mammal ever to walk the earth. A gentle giant that shaped ecosystems simply by existing. Today, only fossils remain, scattered across the deserts of Central Asia, silent witnesses to a lost world. But the lessons of Paraceratherium live on. They teach us about evolution's creativity, about the delicate balance of ecosystems, and about the impermanence of all things. They challenge us to imagine what could be, if only we made different choices. What do you think? If Paraceratherium lived today, could we coexist with such a giant? Would we protect it, or would it disappear like so many species currently facing extinction? Would you want to see a Paraceratherium in the wild, standing tall against the sky? Share your thoughts in the comments below. If you enjoyed this journey into the past and the hypothetical present, please hit the like button and subscribe to our channel. We have many more incredible extinct species to explore, each with their own unique stories and lessons. Until next time on Extinct Species Today, respect nature, preserve the wild.